How do you add behaviors or mechanics to your game objects in Unity? This is done through something Unity calls scripting. Scripting in Unity utilizes the C# programming language in order to communicate the behaviors you want into a form the computer and game engine can understand. Let's start by creating a new folder. We're going to call that folder scripts. This folder is going to be where we store all of our scripts for this current project. So let's go ahead and create a basic C# script. If you're just starting out in Unity, I recommend clicking the Modern Behavior Script option, and we're going to name this Samples. When you install your Unity version, there should be a code editor that gets installed alongside it called Visual Studio. That's what we're going to be using, as it just comes alongside Unity, and it's the easiest thing we could use for the tutorial. Now that we have our script, let's go ahead and open it up. When you're in the coding editor, anytime you see this yellow box, that means that is a change that you haven't saved yet. When you hit Control S to save your progress, it'll turn green. Anytime you need to undo a change, press Control Z, and anytime you want to redo something, press Control Shift Z to bring it back. If, when you're using your coding editor, you aren't getting any of the suggestions that you should normally be getting to autocomplete your function names, this is what you need to do. First, go back to your Unity editor, go to Edit, go down to Preferences. Once inside the Preferences, you'll see the External Tools tab. You'll see your External Script Editor option here. Click the drop down. Make sure the Visual Studio version you're using is selected. Close your script, and then click Regenerate Project Files to make sure everything works properly. Now, upon reopening your coding editor, you should be able to get the suggestions you expect, and you can double-click them to autocomplete, or you can press Enter to autocomplete. To get you started making your own scripts, let's go over some of the basics of C#. Let's start with what a variable is. A variable is a named memory location used as a container to store data values that can be accessed, modified, and reused during program execution. These can be things that vary between number values to game objects. A function is a reusable block of code designed to perform a specific task that usually utilizes various variables within it. Think of it like a list of instructions that the computer has to follow to complete the task. Since we chose the Modern Behavior Script option, you'll see that we derive our new class, which has the same name as our script, from the Modern Behavior class. This gives us access to all of the functions and methods within the Modern Behavior class inside of our new script, such as the awake, start, and update functions we have here. These three functions are a few of the most important methods to learn to utilize correctly. The awake function is called exactly once when the script is loaded, even if the script is disabled. It is generally used to initialize variables or set up references between scripts before a game starts. The start method is called exactly once before the first execution of update. Unlike awake, it only runs if the script component is enabled. That means that you have to have the script component enabled on your game object in the Unity editor. It is often used for logic that requires all objects awake methods to be finished before it executes. The update function is called once every frame the game is running. This is where most continuous game logic happens, like, for example, reading player input or moving non-physics based objects. Also, because frame rates between devices that may be playing your game will vary, you should use time.delta time when moving objects to keep speeds consistent. To utilize it properly, you just need to multiply it by whatever movement calculation you're doing. One good way to keep your code organized is to utilize headers. To use a header, you need to use a bracket, type the word header, use a parenthesis, and then type the name of your header within quotations inside of the parentheses. After you've done that, you need to have a variable beneath your header so that way Unity can recognize it as a header. To see what the header did, let's head back over to our editor and create an empty game object. We're going to drag our script onto our game object. Now that the script is on the game object, you can see that we have our header that we named here called variables, and we have our integer variable underneath it. The reason we can see our integer variable there is because we have the integer variable type set to public. A public variable can be accessed from any other script. That's not going to be important for this tutorial, but it is important to know if you want to do more advanced scripting. As you can see here, I have added a string variable type, but instead of public, I've made it private. Since it's private, you won't be able to see it in the inspector. However, if you add serialized field next to the private modifier inside brackets, that allows you to edit that private variable inside of your inspector. The reason you would want to set a variable as private would be to protect that data from being accessed outside of the script. Here I've listed out the basic variable types you would normally use in C#, as well as some basic Unity-specific object types you would be using in C during development of a game. I have also included a couple types of collections or logic structures that are useful to know about as well. The first thing we're going to talk about are the basic C# variable types that are part of the programming language. This means that they aren't exclusive to Unity, and you can use them anywhere you would normally use C#. For this tutorial though, we're just going to cover the ones that you'd normally use while making a game. These variable types are standard data types used for basic logic and values. The types we're going to cover are int, float, char, string, and bool. The int, or integer data type, is used to store a whole number, meaning any number like 1, 2, or 3, but no decimal values. The float variable type is used to store numbers with decimal values, for example 6.9 or 36.21. Double and decimal types exist. They have more precision than a float, but you don't need that level of precision to create most games. The char, or character data type, is used to store a single character value, for example, the letter A. The string data type is used to store a string of characters, for example, please like and subscribe, and it is essentially an array of character variables. The bool, or boolean variable type, is used to store a logical true or false value. Here is how all of our basic C# variable types appear in our inspector. You can see here that we have boxes to enter integers or text for our integer, float, char, and string variables. And we have a little checkbox here so we can set our bool to either true or false via the inspector. Let's move on to the Unity-specific object types. These object types are part of the Unity scripting API and represent physical or functional parts of your game. You declare these objects the same way you would a variable, and you can use them to reference a lot of different parts of your Unity project. Some of the most common ones you would use are GameObject, Transform, Vector3, Rigid Body, Color, and your camera. The GameObject type is used to store a reference to a game object that's within your game scene. The Transform type is used to store and manipulate a game object's world position, rotation, and scale. The Vector3 type is used to represent 3D points and vectors, X, Y, and Z axes, commonly used for coordinates or directions. The Rigid Body type is used to apply physics simulation to an object. It allows it to be affected by gravity, mass, and other forces you may have in your game. The Color type is used to store and manipulate RGBA values. This can be used for things such as changing the color in your materials at runtime. You can declare a variable for any component such as a camera, audio source, animator, or a collider. Here we declared a variable of camera type, and you could use it to reference your player's camera, which dictates what the player sees in the game view. This could be used for things such as toggling a third-person or first-person view in your game. This is how all of the Unity-specific object types look in your inspector. You can see here that you can choose from your available game objects for your game object variable. You can choose which game object transform variable you're going to access. You can set the individual values for your vector. You can choose which game object to use the rigid body component from. And in your color variable, when you click that box, it'll open up this color wheel where you can choose a different color. For the camera variable, when you click it, it's only going to list your available cameras in your scene. The last data type we're going to go over are some various collections and logic structures. The first type of collection is an array. An array is a fixed size collection of a specific data type. Their size is usually set when created and cannot be easily changed. Here we have an array of game objects declared. Since it's public, you will be able to assign game objects to it via your inspector, and the size of the array is only defined once you actually run your game if you do it this way. Once you start your game, your array is fixed in size and it cannot change. The second collection type, however, is a little bit more dynamic and flexible. These are called lists. Lists are dynamic, resizable collections you can easily add, insert, or remove items from at runtime. Enums, or enumerations, are custom data types that consist of a set of named constants. These are great for state machines or creating drop-down menus in the inspector. Here we have our enum, and we have 4 options for it. And below it, we have declared a variable of our enum's type. This is to store the currently selected value from the enum choices that are defined above. Dictionaries store data in key value pairs. They are highly efficient for looking up data, for example, using an item's string name to find its int quantity. You would use this for things such as creating an inventory system. This is what the various collections and logic structures we discussed look like in your inspector. Here you can see for your array that you can press the plus in your inspector, and you can add any of your game objects to that array. The same thing with your list. You can edit it in your inspector and add any game objects you want to the list, but the difference between the two is in the list, you can access it and change the size and number of objects during runtime of your game, and for the array, you cannot. Here you can see our current option of our enum type, and when you click the drop down, you can see all of the available options that are within our enum. Now that we've covered what variables and functions are and do, let's write a new script to add some behavior to our cube. First, we need to decide what we want our cube to do. Let's make our cube move forward and drop an assortment of random game objects along its path. To achieve this effect, we need to first create a new script. Let's create a MonoBehavior script, and let's name it moveSpawn. We're going to name it this because it's going to move the object and cause it to spawn more objects. Once we have our script, let's open it up so we can start adding some variables. Here we've added a few variables. These are the variables we're going to need for our script. We need a move speed variable for how fast the object is going to be moving. We need a game object array so we have the objects that our cube is going to be spawning as it moves. And we need a spawn interval float so we can control how fast we spawn the objects behind our cube. And we have a timer float here to serve as our internal counter to keep track of the time that's passed. Here in our start function, we're going to reset the timer to 0. That way our timer is reset every time the game runs. In our update function is where we're going to handle the movement itself and the spawning of the objects. This is because update is the function that runs every single frame, so this is where you want to put your main gameplay logic for whatever game object you're trying to make a script for. Here we are accessing the transform of the game object the script is attached to, so you can just use transform.translate. This dot allows you to access functions that are stored within the transform type. Translate is used to apply movement to an object. It takes an argument of a vector that you can then multiply by your move speed and your time.delta time to get an appropriate move speed. The reason you multiply by time.delta time is so that the move speed is constant between all frame rates. After we move our object each frame, we need to increment our timer. That's done here by adding time.delta time to your timer. Here we have what is called an if statement. An if statement is a fundamental programming construct used to control the flow of a program by making decisions. If the condition inside of these parentheses is true, the code within the if statement executes. If the condition inside the if statement is false, the code inside the if statement does not execute. This if statement specifically states that if the timer is greater than our spawn interval, we can spawn an object. If this is not true, we can't spawn an object. This prevents us from repeatedly spawning objects over top of each other every single frame. Inside of our if statement, you can see that we have a custom function here that we're going to write here in just a minute. If statements have a helper statement called an else statement. When you have these together, it's called an if-else statement. That means if this condition is not true, this code does not execute and instead executes the code within the else statement. You don't have to have an else statement to use an if statement though. Now that we've written the custom function that we called within our if statement, you can see that it has turned yellow because the compiler recognizes it as a function. We declared the function as a void type because we don't need it to return any data. Custom functions can also take arguments of any variable type, and you can utilize those arguments however you choose within the function. So say we wanted to add our timer into our random index. How would we do that? We create a float a argument for our function. Then we can add the a down here inside of our parentheses. You can see here that it has flagged our custom function as not having an argument that responds to the required parameter. To fix this, all we need to do is type in our variable name, and that will pass the value for our timer into our custom function and then add it to our random index when we use it. But we don't actually need to do that. Inside of our custom function, you can see that we've used a few functions that are either built into Unity or built into the MonoBehavior class. Random.range picks a random number between a range of predefined numbers. The objects to spawn.length takes our array and uses the .length property. This finds the current length of our array and uses that number for the random range. Then we set this to our random index, and then after we get our random index, we pick that random index object from our array, and then we use the instantiate function to spawn the chosen object into our scene. The instantiate function takes 3 parameters, those being the object to spawn, the position of that object, and the rotation of that object. Here we just call the variable we use to store the reference to the object we're going to be spawning, and then we use the transform.position and transform.rotation of the game object that the script is attached to. This if statement is just a safety check so that the game wouldn't crash in the event that the array was empty when you launched it. Now that our script is ready, let's go ahead and assign it to our cube. Now that we've applied our script to our cube, you can see that we have our predefined move speed and spawn intervals here. We don't have any objects in our objects to spawn list just yet, so let's fix that by creating a few prefabs that have rigid bodies. We added rigid bodies to these objects so that they interact with gravity. So we're going to create 3 elements for our array, and we're going to assign each object once into the array. We're also going to parent our camera to our cube so that it follows the cube as it moves. And now when we press play, we should see a moving cube spawning some objects behind it. Now you can see we have our cube that is moving across our scene and spawning objects behind it as it goes. This is an example of what will occur if you don't use a spawn interval and don't multiply by time.delta time. In this video, we covered the basics of C#, being variables and functions, and how they work in Unity. As always, please comment any suggestions you may have, and if you enjoy my content or want to follow the progress of my game, please subscribe and like the video.